So now we continue on Booleans and we'll also review the logical operators. First, let me revise again regarding the Boolean. It was prepared by George Boole, and he is best known as the author of the Laws of Thought, which contains Boolean algebra. Also a story that once George Boole walked from his home in heavy rain and gave a lecture wearing his wet clothes. He soon died of pneumonia. So, whenever it rains, lecture will be cancelled. So, Booleans are a type of variable that can only be true or false. Here are a few variables. Is raining? The value is false. In class, now it could be true. Car unlocked, false. Voted prom king, false. Project submitted, true. And please note that there are no single quotes around true and false. These are actual values and they are in a proper case. Now, we use logical operators to create Boolean expressions that combine two Booleans into a new Boolean. For example, here we have one Boolean, is raining, true, and no umbrella is also true. So if it is raining, and no umbrella, so it is wet. So wet will be true. And if any one of them is false, if is raining is false, then wet is false. Or if no umbrella is false, then also wet is false. So in AND operator, when is raining is true and no umbrella is true, wet is true. But if either of them are false, then wet is false. Here is what we call the truth table for AND. Is raining and no umbrella. If both are true, then the answer is true, which means in our case the wet condition. So it is raining and we don't have umbrella, so we are wet. It is raining but we do have umbrella. Remember, there is no umbrella, so we do have umbrella, so in that case we will not be wet. If it is not raining and we don't have umbrella, we are still not wet. And if it is not raining, but we do have umbrella, then we are not wet. So the only case for wet is when it is raining and we don't have umbrella. So we use logical operators to create Boolean expressions that combine two Booleans into a new Boolean. There is another example. Swimming is true and showering is true. We are wet whether we are swimming or showering, taking a shower. We will be wet in either case. This is an OR operator. So if swimming is true or showering is true, then wet is true. But if both of them are false, then wet is false. Is a truth table. So if swimming is true and shower is true, so definitely we are wet. Showering or we are true or condition. But even if one is false, swimming is true and showering is false, it is still true, it's still wet. Or swimming is false and showering is true, it's still wet. Only when both are false, then it is false. That is OR distinction. So comparison operators return Boolean result. For example, we saw 5 is less than 1. Is it true or false? 5 is greater than 1, so answer is false. Return is false. Is 5 less than or equal to 2? No, it is still false. Is 5 greater than 3? This is true, so result is true. Is 5 greater or equal to 5? Of course it is not greater, but it is equal, so result is true. And please note, here it is 5 double equal to 4, it means equal. So single equal is assignment, remember, and double equal is the comparison. So is 5 equal to 4? No, so it is false. Not equal means exclamation and equal. So is 5 not equal to 4? Yes, 5 is not equal to 4. So this is true. So result is true. It also works for strings. How? Because strings are just a series of characters. Each character is assigned an ASCII number. What is ASCII number? It is an ASCII chart where all these letters, they have equivalent number. For example, the small a, it has the decimal equivalent to 97 internally keyboard. So when we press a small a key on a keyboard, actually it is 97. And similarly, when we press capital A on the keyboard, it is 65. And we don't need to memorize these numbers, but the thing to note is that all these capital A until capital Z, they are the contiguous same places between 65 and 90, and also small a to small z are continuous, and capital A is actually smaller than capital A, smaller a. It is also true when we sort file name. If you see in your file manager, so all proper case names come first and then the lowercase, and this is the reason why capital letters come first, because you can see that the ASCII code is smaller than the smaller letters ASCII code. And we also have ASCII code for these special characters and numbers. So not important to know the ASCII codes. Worth knowing, letter codes are in alphabetical order and uppercase ones come first. And important to note, characters map to numbers, and strings are a sequence of characters. So is A less than B? Yes, A is less than B, so answer is true. Is A greater than D? No, it is false. It's interesting. Is capital A greater than D? False. All uppercase are lower than lowercase. Is lowercase a greater or equal to A? It is not greater, but it is equal, so that's why it is true. Is A not equal to A? No, it is false. They are equal. Is A equal to Z lowercase? No, so it is false. It is interesting. Is AB greater or equal to AA? The first letters equal, A is A, so go on to second letters, and B is greater than A, so it is true. We use parentheses to group Boolean expressions together. So test taken is 3, labs done equal to 5. So test taken is 3 and labs taken greater or equal to 6. So in that case, course done is true. So in this case, is it true or not? So test taken 3 is 3 equal to 3. Yeah, so this is true. Are labs greater or equal to 6? No, it is false. So the net answer is false. Okay, so miles is 3000 miles since last oil change. Months, 7 months since the last oil change. So you own car is false. Do I own this car? No, it's false. So we change oil if own car and miles greater than 5000 or months greater than 6. So under what conditions will I change the oil? Either we own the car and this condition. So given these values, will I change the oil? Let's evaluate. First we do these parentheses. So R miles greater than 5,000, 3,000 is not more. So this is false. It is or, so check the remaining. Is months greater than 6? Yes, it is 7 greater than 6. So this whole thing is true, because of true. So do we own the car? No, false. So it is false. Let's draw 5 here. So you need to own the car. So what about now? So do we own the car? It is false. And miles not greater than. So this whole thing is false. But now we have or month is greater than 6. So this is false. But months is greater than 6. This is true. And we have or in between, so the answer is true. Okay, here is another variation. So not own the car. So what do you guys say now? Let's check this parenthesis. Is 7,000 more than 5,000? Yes, so this is true. Or months is less than 6, but it is or, so the net answer is true. And own car is false, but not own car, it means it reverses, so it is true. So true and true is true. Also, did you notice how I broke the long line? Python lets you break any line with parentheses. So once parentheses start, so you can break the line. Line up the next line below the opening parentheses. Let's take some more examples. Are you not excited for the weekend? It's just confusing. If I say, are you excited for the weekend? And you say, yes, I am excited. So it is true. Are you not excited? It is false, because I am excited for the weekend. Now, have you had coffee or tea this morning? So, how many of you got coffee this morning? Maybe a few of you. How many got tea? Maybe a couple. So either one. So whether you got coffee or tea, all of you stand up, raise your hands. So both will be counted. So are my favorite animals jellyfish and frogs? Both have to be. How many of you can say jellyfish and frogs? Now, do we have Monday and not Tuesday off for Labor Day? Yes, Monday is off and Tuesday is not off and not Tuesday off. So Tuesday off is false, not will become true, but this is true. Yeah. Now let's take an example, some programming practice. Write a program that asks the user for the name of the company they work at, and how many years they have been at the company, and prints out how many weeks of vacation time they have. So how many inputs we need here? Need the name of the company and how many years they have been working at the company. And this is the logic. Facebook gives all employees 4 weeks of vacation. So 4 weeks of vacation time is 4 weeks. Amazon gives new employees 2 weeks of vacation. And employees who have been there 1 year or more, so greater or equal to 1 year, then they get 3 weeks, otherwise 2 weeks. Google, they have more comprehensive plan. They give new employees 3 weeks of vacation. Employees who have been there for 3 years or more, they get 4 weeks. Those who get 5 years or more, they get 5 weeks. So let's plan it. So in this example, we need 2 inputs. In these 3 companies we check, and we have to check and further nested if they have the vacation time. Okay, so we go to our idle. So open our editor, and here's the shell. So first, let's always print some message to we know that what we can say vacation times. Let's see everything is working correctly, and I run my code and I get okay, code is running, save and working. So we need to get the input. So get input, get company name, so get user input. So first is the company is equal to input, enter company name. Now what will be the format? It will be the string, and string is fine. Second thing is the years, how much experience. Now it could be string, but we can convert it into integer. So integer input, enter number of years. Okay, now we need to check the logic, right? So how much vacation can we have? We can say check for Facebook. Here is the logic for Facebook. If company is equal to Facebook, if company is Facebook, how much is the vacation time for Facebook? All employees get 4 weeks of vacation. So then we say vacation is equal to 4. Okay. If company is equal to Amazon. Actually, since we are using 3 companies, we should put, we can write over here what the person should type. You can say you can type Facebook, or you can leave it blank, and otherwise we'll say we don't have any concept. So what about Amazon? What is the logic for Amazon? For Amazon, it is 2 weeks for new. If it is less than 1 year, and 1 year or more, we get 3 weeks. So in this, if it's Amazon, it is not same vacation. We need a further check. If years is less than 1, then vacation equal to 3. The vacation equal to 2. Otherwise 3. Vacation is 2. Else vacation equal to 3 weeks. And if company is equal to Google, in that case, for Google, if it have been 3 years or more, 4 weeks, and 5 years or more, 5 weeks. For new employees is 3 weeks. So if years are less than 3, then vacation is equal to 3 weeks. And if years is less than 5, less than 5. So these will be 0, 1, 2, and this will be 3, 4. So vacation is equal to 4. Else, if it is 5 or more, vacation equal to 5 weeks. And what about if there is any other company and we don't know, vacation is equal to, and we don't know. And now we can print it. Print vacation time, and we need to convert into str because it is integer. So let's see. Control S. We run it. So enter company name. If I type Facebook, number of years, let's say 2, vacation time is 4. If I type again company Facebook, let's try this time, try Amazon, and next there will be 0 years, vacation time is 2. And we decided company name is Amazon, and this time number of years are, let's say 2, so vacation is 3. Now let's try Google. If it is 2 years, vacation is 3 weeks. And if it is 4 years, it is 4 weeks. And if it is 5 years, 5 weeks. And if I try some company which is not in my list, like Microsoft, you see the vacation time is not available. So here's an example of nested if. We have this if condition, 3 companies, and we have this nested if. Now let's take another example. So covered this one earlier. Just to make a summary again, we can use these Venn diagrams for our logic operators. For AND, both conditions have to be true, both terms. And for OR, it is the union, so it covers both, either one. And for NOT, it is the other one, just one term. some more example. So if my price is, let's say 40, price is 40, so this one is, price is 40, this one is true, but this not make it false. If price is 60, then 60 is not less than 50, so for 60 it will be true. So price is 70 or price is 75. So if I say my price is 50, so it is false. If I say price is 70, this is true, this is false, but it is overall true. So in this case, price is greater than 20 or price is less than 40. So if my price is, let's say 40, this one is true, this one is false, so it is false. But if my price is 30, then this is true, this is also true, so answer is true. And let's say price is 50. 50 is not equal to 50, so this is false. 50 is not greater than 60, but it is not, so this is true, so answer is overall false. So let's say if price is 60. 60 is not equal to 50, so this is true. 60 is equal to 60, so this is true, this is false, so answer is false. Let's say it is 55. 55, this is true. Now this 55 is not more than 60, so this is false, but it becomes true. So 55, the answer is true. One more example. Let's say price is let's say 5. This is true. 5. This is true. 5 is not more than 10. This is false. This is false. This whole thing becomes false, but all is yes, the answer is true. And let's say price is 15. If it is 15, this is false. But over here, 15 is more than 10, so this is true. This is also true, so answer is true. So both are true. I mean, this is true, so this answer, both are true, so answer is true, but this is false. But OR operation answer is true. Okay. Also, there's a common mistake over here, and we are combining these logical. Is my score between 80 and 100? So the correct answer is score is greater than 80 and score is less than 100. Students have the tendency they just write score is greater than 80 and less than 100. Remember, and is combining two operators together. So each these relational operators should be surrounded by two values. The score is greater than 80 and it must be score here again less than 100. Similarly over here, score is greater than 95 or score is less than 70. We can tendency score is greater than 95 or less than 70. Score should appear with both these operators. Score should come with 95 or score is less than 70. Now score is not equal to 100. This is the way we should do. Not like a score. Not score is equal to 100. Now let's make one more game. So write a program that prints the outcome of a bet on come out roll in craps in the game. The program should first ask the user for their pass line bet in dollars. So how much bet they want to put. Then ask for a roll. A roll is a sum of two 6-sided dice. So if the roll is 7 or 11, then they win double their bet. If roll is 2, 3 or 12, they lose their bet. In all other rolls, the bet carries forward to the next roll. And we haven't covered random numbers yet, so we'll just use the input for these two dice. So we may get 3 input, one for the bet, one for dice 1 and dice 2, and then we can add them. Roll will be the sum of the two 6-sided dice. This is our logic. So we can continue on this case. We can make a new program, call it, save it, call it 05 crash game. So we need to get the dollar amount, get user input. So bet equal to, could be float if you want to enter decimal portion or just integer input, enter bet amount, got the bet amount. We may have dice 1, dice 1, and we can have dice 2, dice 2. Now we can say dice equal to dice 1 plus dice 2. We got these. Now here is the logic. This is the determine the winner in the next row. So what are the conditions? Conditions are if roll is 7 or 11, we win and double their bet. So if dice equal to 7 or 11, so this is dice equal to 7 or dice equal to 11. So here is the OR condition. Dice is 7 or dice is the sum of two dice. In that case we print you win and what is the amount? It is double the bet. So either we can, in this case, double the value of bet. Bet is equal to bet times 2, and we print the bet. And if dice roll is 2, 3 or 12, you lose the bet. 2, 3 or 12. So dice equal to 2, the typo here, it is 2, or dice equal to 3, or dice equal to 12. So for 2, 3, 12, for 2, 3 or 12, we lose the bet. So we can just say print you lose. You lose the bet. And so you will double bet. And the third case, the final case is else part For all other rows, the bet carries forward to the next row. So in the else part, you can say print row for the next row for the, or continue for the next row. Continue for the next row. So let's see again. So we got the bet, we got the dice 1, dice 2, and we got the sum. So we determine the winner. So dice equal to 7 or dice equal to 11, double the bet and you win double. Print it. And dice is 2 or 3 or 12. There is a nice logical operators, or then you lose the bet and else part you win. Save it, we run it. So enter the amount. It should be amount, not amount. Let's say amount is $10. Dice 1 is, let's say 4. It is 3. So you win and we get the double. And let me fix it, make it amount. So now if I, let's say bet is $50 and I get 5, 6, then again you win double the bet, $100. And now if I get the amount, let's say $30 or 39 or any amount, 39, and I get dice 1 and 2, so you lose the bet in this 3. And if we check the other cases, let's say amount is $40, and now let's say we get 5, 3 and 2, 3 and 2, continue for the next loop. You can try other cases as well. So what did we learn? So conditionals can be nested inside one another, as we saw in that example for the companies Facebook, Google. To trace nested conditionals, we need to look very carefully at the indentation. Boolean expressions can be combined using logical operators, and not expression is true only if the expression evaluates to false, and AND operation is true only if both expressions evaluate to true, and for all, at least one expression evaluates to true. There are other logical operators besides AND or NOT. We'll encounter these later. Thank you. Okay, welcome to our lecture regarding variables and input. So before starting variables and input, let's refresh our previous lecture. So in the previous time we covered